Welcome all. Welcome to this video lecture series on the design and analysis of algorithms. In this video lecture, we will look at the Sudoku problem. That is one of the famous problem that's people try in even in these times when we are free most. Then we will try to solve the Sudoku problems. So internally in our mind, we are using a backtracking approach. We know that we are solve the problem, but internally we are using a backtracking approach. So that's we'll try to visualize using this video lecture that how the backtracking approach, that is one of the technique in algorithm that try to solve the problem, because the backtracking, using backtracking you can get the answer to all the problem. So this lecture we will try to demonstrate the use of a backtracking in solving the Sudoku problem. So let's take the example of a Sudoku. That is one of the Sudoku. It's a 9 cross 9 grid and that is full with the numbers. We have to make sure there are certain conditions that we have to fulfill. Now how many conditions? First conditions, in each row, let's say this is each row like this, we have a number from 1 to n, 1 to 9 here because it's a 9 cross 9. Now in each column also we have to make sure we have a number from 9 to 9, and thirdly within this particular 3 cross 3 grid the number is not repeated. So let's say this 5, then 5 won't be repeated in the same column, same row, or in same particular 3 cross 3 grid. So that is what makes this problem more interesting, more complex to solve, to understand. So let's try to use the backtracking methods. So in the backtracking, how it works, we start with the first row. That's we can do it here, the first empty box, because this number that is given to you, that you are not allowed to change these numbers. So first we will put one, check out, start with the 1. Can we put a 1 here? If we put 1 here, yes, 1 is common, in not in available in this row. It is just the 1 available in this column. Oh no, it is not available. And within this particular box, yeah, 1, that is fine. Now we can come here. Can we see 1? 1 is already used here. 1 is not possible. 2, we will try the 2. The 2, yes, in the same row 2 is not available. In the same column the 2 is not available. That's what it is good. And within the same particular this 3 cross 3 grid, again the 2 is not available. Go on. 7 is fixed. Can we use 3 here? No. 3 is also used in the same row, same column. No. 3. 4 can we use? Yes, 4 is possible. 4 here within the same grid, this particular 3 cross 3 grid, it is unique. In the same row it is unique, in the same column it is unique. Now we come here, we will check out 5. 5 is already used. Can we use the 6? Oh, 6, that is already used here, so we cannot use the 6 here in this particular grid. 7, well, 7 is already used here. 7 is not possible. Can we use the 8? Yes, 8 is possible. The same column, same row, and this 3 cross 3 grid, 8 is the unique. Good. Now the remaining, there are two numbers that we have. Either we can use the number 6 or the number 9. Now if we can use the number 6 here, that is not possible because 6 is valid the constant here. The 6 won't be there. 9 can we use? Yes, 9 is possible in the same row, same column, in 3 cross 3. 9 is not used. Gone. Now the only number remains, that is 6. Well, we cannot use the 6 here, so we have to again backtrack here. We have to check out, do we have any other possibility other than 9? But that is the only 6. That is not again useful, so again we have to come out, check out here. Other than 8, the only two numbers, that is 6 and 9. Can we use the here 6? Now here the 6 cannot be possible here because 6 is already used. The 9, yes, so let's cut the 8 here. We will put the 9 and we will check out that is possible. So if we put 9 here, so let me try to erase certain things that will be kind of easy for you. Okay, so the moment we put the 9 here, we will come here. Now we have a possibility. First number is 6. We cannot put a 6. Can we put it? Can we put a 8? If we put a, can we put 8? Now, if we put a 8 in the same column, it will be there. So that's why we cannot put the 8. So again, we will come back here because we don't go more ahead here in the 9. We will come back here, we will check out other than 4. Can we put any other numbers? 5? No, 5 cannot be put here. 6, can we put the 6 here? 6 is, yeah, so that's why we'll cut down here, we will put the 6. So now you can see that if we continue in this particular manner, then using the backtrack, generally in our mind we will try in the similar way with some intelligence that okay, we will put some numbers, we will try to check out again. If we thought that at some point of time we have make any mistake, then again we will try to go in that particular, and then we will try to resort that mistakes, again we will rechange the numbers and we will continue. So that is what the backtracking method actually we are using in our mind internally, that we are trying all possible things, and it may happen there are multiple solutions for a same Sudoku, but out of that the one solution that is quite possible, that's we have given as the answer. So that is what to do. So if we are using a backtracking method, that will give us all the solutions, but the only problem that with the backtracking is that the time, the resources, that is much more. So to solve this problem it will take much time and kind of resources it will take, so that's why that is a problem. But you get all the solution, that is what the advantage. So it's like if you are putting a kind of Sudoku challenge in some competitions, and where you have multiple answers that is possible, then using the backtracking, first you will kind of calculate the answers, then when you have answers you will try to check out whether that answer is possible there or not, and then you can continue. So that is what the backtracking do. So now you can refer for more details of the Sudoku as well as more details on the backtracking, whatever we have done in the previous slides. That's actually, this is a backtrack, that is what we internally generate a state space tree. So that's also you can look it in the reference books in the syllabus. Also you can look the other videos that is posted to look at what is the state space tree. You can also look at the NPTEL videos, MIT's, any other videos that you can find on the backtracking on the Sudokus, and you can check out that using some intelligent methods that can be solvable in a given time. Thank you for watching this video.